Hi everyone, welcome back to another physics lab. Today we're going to be doing projectile motion, which is a very fun lab. It's sending things flying through the air and focusing on their X and Y motions. That X motion, constant velocity, the Y motion, constant acceleration. Now, this is going to be one of our trickier labs, so pay close attention, make sure that you have set things up correctly, and understand what it is you will be measuring. Now, the setup has two main parts. First, we need 1 meter of flat surface. I usually set my meter stick right at the edge of my table, tape it down. We go 1 meter over, and then we will have our ramp. The ramp can be straight, it can be curved as well, because we don't actually care if the ramp causes constant acceleration. What is important is that our ramp goes up to a height of at least 30 centimeters, because we're going to be dropping our object from 3 specified heights, from 10 centimeters, from 20 centimeters, and from 30 centimeters. Now, I typically will go ahead and measure and mark those ahead of time. So I'll measure a height of 10 centimeters, either put a piece of tape or use a marker to mark 10 centimeters, 20 centimeters, and 30 centimeters. That way I can ensure that I am dropping my object from the same height every time. That's our basic setup. Now let's talk about the 3 things we'll be measuring. We're going to be measuring time. That time is the time it takes to travel 1 meter. After we measure time, we'll measure time 3 separate times and take an average. We'll then measure vertical height. We'll take that vertical height and compute a falling time. And then lastly, we're going to be measuring the horizontal distance that the object travels. Now let's go through that process. First, you'll be measuring the times. We're going to be setting our ball at some specified location, doing 3 trials at 10 centimeters, 20 centimeters, and 30 centimeters. Again, those are vertical heights, not straight up the ramp, not horizontally, but vertical heights. Once you're ready to drop your ball, you will drop it. We don't start our measurement when we release the ball though. The time is the time to travel 1 meter. So we want to start our stopwatch once the ball hits the flat section. The flat section, it should be undergoing constant velocity, and that's what we want to time. So we would drop our ball, start our time, and stop our time as it goes over the edge. After doing that 3 times, you can take an average and then you can compute a horizontal velocity. We know it's roughly constant velocity. It traveled 1 meter in our average time. The velocity is 1 meter divided by your average time. The next measurement we need to make is the height of our table. Measure from the floor to the surface of your table. Make sure to convert that measurement into meters. That measurement will be the same for all the trials because it's falling from the table to the ground no matter whether you drop it from 10, 20, or 30 centimeters up the ramp. With that measurement, compute a falling time, T sub y. The time it takes to fall the distance y from the surface of your table to the floor. Our final measurement is probably the most important. It is the actual distance the object travels, or the range of the object. Use a plumb bob, which is just a heavy object on a string, a mass on a string, and lower it directly below the edge of your table. You can then mark on the floor the spot that is directly below the surface of your table. You will then let the ball roll, fly off the table, and ideally you will place a piece of paper where it lands, tape it to the floor, and then use some carbon paper or copy paper gently placed on top of that to mark where the ball lands. You can get some copy paper, some carbon paper at some office supply stores. Possibly you could ask your local university if they can lend you a sheet. But if you can't track any down, you can also use a partner to watch carefully. Your eagle-eyed partner can spot the exact location the ball strikes the ground and mark it. And then you will measure from directly below the table to where the ball lands. That would be your X experimental value, the experimental horizontal distance. You'll then compare that to a predicted value or a calculated value that you can calculate from your horizontal velocity multiplied by the time to fall, the falling time. The last step in the lab is to compare those, find a percent error, and then you'll make a plot to help answer some questions later. The plot's a little weird because we'll be putting the X experimental value on our y-axis. That is X experimental on the y-axis, and then the X velocity, Vx, on the x-axis. We do that to make sure we get the right units for our slope. But you can see that as you finish up the analysis for the lab. If you have any questions, as usual, make sure to talk to your professor either about the setup of the lab, how to take data, or how to perform your calculations. Otherwise, good luck, and I'll see you next time.